Is your answer. I'll start the next one. Okay. Alright, I'm going to be doing some adding and subtracting with polynomials. We talked about polynomials yesterday. Easy stuff again. Alright, first thing I've got here, this says negative 3z to the fourth plus 2z cubed plus z to the fifth minus 6z. Okay, no adding or subtracting on this one. The directions on this say to write the polynomial in descending powers, in descending order of the powers. This would be called, this is what Algebra 2 was doing a little bit yesterday, this is called standard form when you go in descending power, in descending order of the power. So all we can do here is look and see our highest power is z to the fifth, so we would put that one first. Next I got negative 3z to the fourth. Next I got a positive 2z cubed. And then I got a negative 6z. So that'd be it, you just rewrote it. Now one thing that they struggled with a little bit yesterday is they thought when I moved stuff around, like if it was being subtracted, I needed to add it or whatever. No, we're just rearranging inside there. We didn't go across an equal sign. You only do add and do the opposite operation when you move it across the equal sign. We didn't move anything there, we just reordered it. So that'd be all you need to do on that. Okay. What would the degree of that, you remember what degree means? What would the degree of that polynomial be?
5.
Very good, Leah. It is 5. You get that because it's just your highest power. Okay, highest power is 5, so it's a degree of 5. The leading coefficient of that polynomial, I don't know if that's coefficient. The leading coefficient, we know coefficient means number in front of the variable. Leading coefficient is the one that corresponds with your degree. So if I'm looking for the leading coefficient, I go to my term that had my degree, and I get the coefficient of that term. So what would the coefficient of this term be? 1. Very good. Now some of these things, some polynomials have special names. This one has 1, 2, 3, 4 terms. So it doesn't have a fancy name. I made one up. I always say quadrinomial, but I just made that up. So it doesn't have a special name. We know if anything has 1 term, it's a monomial. 2 terms, it's a binomial, bless you. 3 terms, it's a trinomial. And then anything after that, we just call it a polynomial. It doesn't have special names anymore. Okay? Okay. Degree, names, we did all that. Turn the page. Alright, now let's do what we're here to do, the adding and subtracting. I got 2z to the fourth. Don't know why z seems to be the favorite today. Oh, plus 3x to the fourth. Mixing it up a little. Stirring the pot. Plus z to the fourth. Minus 9x to the fourth. Alright, we're given that polynomial there. The directions say to simplify. So, only way we can simplify is if we have any like terms. To be like terms, this is middle school stuff here. The variable's got to be exactly the same and the power's got to be exactly the same. So I would say, here's a z to the fourth. Do I have any more? Yep, right there. Okay, so I got 2 z's to the fourths and 1 z to the fourth. That's 3 z to the fourth, right? Are you okay on that? Here I got an x to the fourth. Do I have any more of those? Yep, right there. But this one's got a minus sign in front of it. So 3x to the fourth minus 9x to the fourth is negative 6x to the fourth. And that's it. Don't combine those because z and x is not the same. Woohoo! Yes, Miss Lynch.
What would the leading coefficient be then? Would it be both?
Woo! Yeah, I think so, because the degree would be 4, so that would go to both of them. That's a pretty good question there. Alrighty, let's look at one that's got multiple stuff in it. before we get on. 5x squared z minus 3x cubed z squared plus 8x squared z plus 12 plus x cubed z squared. And again, the directions say to simplify. All right.
To the second z.
Okay, good. Austin found I got an x squared z pair that I can add there, right? 5 of these plus 8 of these. Gives me 13 of those. Powers stay the same when you add. Very good. Now are those other things like terms?
X3, Z2.
Yep. So here I got -3 of them plus 12 of them.
9.
Add here. That'll be it. Now, do you know that answer that I circled? Do you know what the degree of that is? Nope. Nope.
Oh, I know it's a binomial.
It is a binomial. Yep. 5. Good, Katie. Where'd she get 5?
3 plus 2.
This side we had a 3 plus 2. This side you had a 2 plus 1. So you had 3 and 5. 5 would be bigger.
What's that called again?
Degree.
What's the degree? So that's for the highest degree.
Would have been in the 9. Yep. 9.
Because that's what's
Alrighty. Couple of different ways we can add these things. We're fixing to add a couple of polynomials. This thing started off as just one big polynomial, and we simplified it down to a binomial. But now we're going to have polynomials to add, and there's a couple of different ways we can do it. This one says -6r to the 5th. I'm going to do it both ways with you, plus 2r cubed minus r squared. I want to add that to 8r to the 5th minus 2r cubed plus 5r squared. Alright, 2 ways I know to do this. The first way I'm going to do it is what I would do on my own, and basically just depending on how the problem is written. But if I was given the problem this way, this is the way I would do it. I would just go, this is when I always say I'm going like term hunting. I get over here in this parentheses, I got a -6r to the 5th, and I go to the other one and hunt and see if I've got an r to the 5th. Yeah, I do. So I'm going to add those, -6r5 plus 8r to the 5th, that's a 2r to the 5th. Okay, then next on my left side is 2r cubed, so I go hunting on the other side for one of those. I got one right there. 2 of them plus -2 of them, that's gone, yep, yes ma'am. And my last thing, I got a -r squared and a 5r squared. -1 plus 5 is +4. So that'd be it. Okay, now other way you can do that, you could, remember when you were a little tot and you first started learning how to add, when things had more than one number in them, you stacked them. So you could do that. That, in my opinion, if it's written that way already, go for it. But if not, it takes longer to write it like that to get it ready than it does just to add them. But you see here, negative, you got to make sure they're lined up like terms. If they're not, you got to rearrange them and everything. That's why we have that opening bell ringer where we rearrange stuff. Wasn't a bell ringer, that opening problem. -6 of them plus 8 of them. So 2 of them. 2 of them plus -2 of them is nothing. -1 plus 5 is +4. So we get the same answer. And that was easy to do, but you had to go to the extra steps of setting them up that way. So it's just up to you which way you want to do it. Doesn't matter to me. I just tend to do whatever, however it's written. Alright, I'm going to give you 2 to do on your own right quick. No, just add them. Oh, we're actually subtracting now, my bad. We're just going to subtract. Alright, first one's got p to the 4th plus p cubed plus 5 minus, we changed to subtraction, minus 3p to the 4th plus 5p cubed plus 2. There's number 1. And number 2, I'm going to do 2k to the 3rd minus 3k squared minus 2k plus 5. I'm going to subtract 4k cubed plus 6k squared minus 5k plus 8. Alright, so I gave you 2 different problems and I set them up 2 different ways. You can subtract them any way you want. Go.
If you have that minus sign in the middle, it would make the 3p of 3p4 negative.
Well,
You want to start off with a gradient coefficient?
no, you don't have to do that. Just subtract. I would say that as 1 minus 3 would be the way I would read it. You don't have to, all you got to do is subtract them. Don't have to worry about the degree and all that now.
Trinomial.
And it wasn't my fault. It was Sam's fault. And then she told me she didn't say anything. I was like, you're joking. You decided not to validate it.
That would be a bad deal. Alright, on number 1 up there with your P's. What did you get, Caleb? Minus 3. Alright, let's talk about this and see if we need to change anything. What do you think, Scout? What can we add or do different? Is this good? Do you agree?
No. Hey, she didn't ask.
That's right, I asked Mr. Pugh. Talk to me, Mr. Pugh. What can we do to help Caleb out here?
Well, first we give her a tutor.
Scout, that's you. You're the tutor. Okay, go ahead.
I don't know. Those two need to be negative, and the 3 needs to be positive.
Okay, 1p to the 4th minus 3. So 1 minus 3 is a negative 2. Good job. Okay, then he talked about this sign. 1 minus 5, that's also negative, so we're getting somewhere. 1 minus 5 is negative 4. And then the last one, 5 minus 2, positive 3. Good job, Scout. I think Caleb was testing me. Right, Caleb? Yeah, that's what I figured. Good job.
Oh,
Everybody all right now?
I totally excluded
You did what?
I didn't even think about the minus sign. I added everything.
Oh, yeah. Yeah. All right, on the bottom one down here. On the bottom one down here, Angie, what'd you get?
Negative 2k cubed minus 9k squared plus 3 minus 3.
Girl.
All right, let's check through that. 2 minus 4, that is negative 2. Negative 3 minus 6, that is negative 9. Negative 2 minus negative 5, that's positive 3. 5 minus 8, that's a -3. Scout, you give it your approval?
Yes.
Good job. You've got the pretty high standard to get Scout's approval, just so y'all know.
I think it's because you were already circling, like you usually circle the answers, but I guess I better agree.
No,
You
he
did
had,
good.
he had.
Is that a wrap?
Almost. We'll give you one with both steps.
That's a polynomial.
There you go, Coach Wright.
There you go.
Any tissues?
I got some paper towels, yeah. I like it that we foster a friendly environment, but don't be making fun of it.
What in the world are you doing? All about that.
5. Whoa. Question.
I think you're trying to decide whether to run it.
These big parentheses, bracket, parentheses, because all that is close. And then it keeps going.
Katie, why are you instead of doing it out
Okay, let's see if we can read this.
I can't.
Me either.
5K minus open parentheses.
Alright, I got 5K minus, 5K minus, 2K minus, 4K minus 8K. Close all that up. 11 plus, 11K minus, 9K minus 12K. It's 9K minus 12K. We're already in a room and squashed it all in there. 9K minus 12K.
These are all like
They are, which that's good.
Makes it
Okay?
easy.
That's right. Notice what Leah and Austin are talking about. They're all K's. So they all are like terms. So since they all are like terms, I'm going to start inside of groups. Because remember, in your order of operations, parentheses comes first. So inside of groups. So I know I can simplify this group, right? Let's start down here. 9K minus 12K, that's a -3K. Now that came following a minus sign and an 11K, right? 11K minus -3K. Okay, so I'm done with that spot. Okay, this big parentheses, bracket, parentheses go to the inside of it. 4K minus 8K, it's -4K, right? Then you still got 2K minus that. So that gets me 6K. But then you got 5K minus that. See, I brought down this last 5K there.
Why wouldn't you multiply the 2K and the -4K?
Because that's a minus sign. So we were subtracted. We did 2K.
Oh, yeah, okay, I see it.
So that would get me a -K. Okay, so that was all out of that big middle group with the parentheses, bracket, parentheses with -K. So what we're looking at now, we've got still 5K
Minus K.
minus -K, then plus
11K.
11K minus -3K. So we've got it a little bit more simple.
Then it'd be 6K.
Okay. Now it's just going to go left to right. So this 5K minus -1K would be 6K.
Plus
6K plus 11K, 17K. And then that minus -3 is the same as adding.
20K.
I wish I
Go
could
back.
Good job.
I have 20K in my pocket.
Where you lost it, Louise?
No, we had the 6 and 11. I don't know. I can ask that up. I don't know. I just don't know.
All right, how'd you do? Did you follow all that?
Got it. I got it.
That's okay.
Actually, we have 2.
Just kidding. All right, everybody all right?
Yes, ma'am.
Tomorrow's stuff goes to the function notation. Shall be quiet, we're almost done. You're going to be simmering down. Tomorrow's stuff goes to the function deals where we do like g of f of 3. Remember all that f of g where we have to substitute them all in? It also goes to graphing some of these things. The graphs that look like snakes and stuff like that. So that's what we'll be looking at manana. All right?
Manana.
Good deal.
What is that?